According to the priority list, whichever comes first in the priority list will be considered as the principal functional group. C double bond C, it is alkene. Alkene never comes as a prefix, it will be always a suffix, and that too the primary suffix. Benzene ring, it is substituted by a NH2 group, it will be called as aniline, right? The special name is aniline. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So in the last session, we discussed IUPAC nomenclature of alkanes, that is straight chain hydrocarbons as well as branched chain alkanes, right? Yes, the different rules with which you have to name the branched chain alkanes also we discussed in the last session, and then the naming of cyclic compounds as well. Right. So in today's session, we are continuing with the IUPAC nomenclature. Now the naming of organic compounds containing functional groups. Okay. So when the organic compound is also containing functional groups, how would we name it? Right. And the naming of compounds with polyfunctional group. That means more than one functional group is present in a single compound. Then how would you name it? And then nomenclature of substituted benzene compounds. Okay, so let's begin with the first one, that is naming of organic compounds containing functional groups. So if functional groups is present, how would you name it? Okay, so the parent chain is the one which has functional group directly attached to it. So as we studied in the rules for naming the organic compounds, we know that first what we have to identify the longest continuous carbon chain, right, which is called as the parent chain. So in the case of organic compounds containing functional groups as well, the parent chain should contain the functional group as well, right? And the numbering should be done in such a way that the carbon linked to the functional group gets the lowest number. And when the functional group itself contains carbon atom, then that carbon atom is assigned number 1. Okay, so as in the same way we have studied in branched chain alkanes, yes, the branches should be getting or numbered the lowest possible number, right? In the same way, the functional groups, if in the organic compounds functional groups are present, the numbering should start from that side, or the functional group should get, that is the carbon attached to the functional group should get the lowest possible number. And in the cases where the functional group itself is having carbon atoms, then we should start numbering from that carbon atom. For example, carboxylic acid, aldehyde, ketone. In all these cases, you can find carbon atoms in the functional group itself, right? Yes, you can see the carbon atoms in these functional groups. So the numbering should start from there, right? So let's take an example of the first compound that you can see. So as you can see, there is an OH group present, right? So there is an OH group present. That means your compound is an alcohol, right? So now how would I name it? So when the functional groups is present, the naming should be done in such a way that the functional group should be in the suffix. That happens only if there is only one functional group. Okay. In both these cases, as you can see, there is only one functional group. So the name of the functional group will be attached to the root word as the suffix. So in this case, what is the root word? From where do I start numbering? From the functional group, right? So 1, 2 and 3. Okay, so there is 3 carbon atoms. That means the root word is prop, right? P-R-O-P. It is prop. And the primary suffix will be, it is an alkane, right? Yes, so it will be A-N. We do not write the E. Then we write the suffix for your alcohol group, which is O-L. Okay, so if alcohol group is, that is the functional group is OH, then the name of the organic compound should end with ol. So what is the name of the compound? It is propanol. And the alcohol group or the OH is present in the first carbon atom. So you need not mention 1 there. Okay, so let's take this example. As you can see, again 1, 2, 3. 3 carbon atoms are present. So, and the functional group OH group is present here. So, from either side, if I number it, it will be the same because it is symmetric, right? So, if I am numbering 1, 2 and 3. Okay, again what is the root word here? Yes, it is prop. It is again prop. right? And the primary suffix will be an, right? Propen. And on the which carbon atom your functional group is present? On the second carbon atom, right? So it will be 2-ol. So in this case, you have to mention the position of the functional group, that is on which carbon atom the functional group is attached. So this is in the case if only one functional group is present, that is the name, the root word will end with, that is the suffix will be the name of the functional group. Okay, so I hope it is clear, right? So naming of compounds with polyfunctional groups, that means more than one functional group if it is present, there is a slight change in naming the organic compound. If there is more than one functional group present in a compound, then one of the functional group is chosen as the secondary suffix and the remaining functional groups are treated as substituents. The functional group with higher priority in the sequence given below is termed as principal functional group. So that means if more than one functional group is present, okay, according to this priority list you can see, which we will be discussing now, according to the priority list, whichever comes first in the priority list will be considered as the principal functional group, and the other functional groups which is present, they will be considered as the substituents. So the name of those substituents will come in the prefix, and the principal functional group, whichever comes in the priority list first, right? So the principal functional group, the name of the principal functional group will come in the suffix. The substituents, that is the other functional groups, will come in the prefix. So this is the order of priority. So the highest priority goes to carboxylic acid, then comes sulfonic acid, then there is ester, then acid chloride, this is amide, this is nitrile, and then you have aldehyde, then this is ketone, then you have alcohol, then NH2, then what is this? This is double bond, right? So that is alkene, then you have alkyne, then this X stands for halogens, right? Fluorine, chlorine, bromine, iodine, the halogens. Then NO2, that is nitro, and then R. R stands for any alkyl group, that is CH3, C2H5. Yes, the alkyl groups will be having the lowest priority. Then the highest priority goes to your carboxylic acids. So before moving on to further examples on IUPAC nomenclature, we need to understand how to prefix or suffix it based on whether it is a substituent or the principal functional group, right? So as you can see here, if the carboxylic acid group, if it is present as the prefix, you name it carboxy, right? And if it is suffix, you end the name with oic acid. Prefix comes in the beginning and suffix comes in the end. That is already clear. Prefix, then you have root word and suffix. Yes. Then the next one is amide, CONH2. So if it is a prefix, it is carbamyl, and if it is suffix, it is amide. Okay, and then CHO, it is aldehyde. So aldehyde, if it is present as a substituent, then we use it as a prefix, right? So the prefix word is formyl, and the suffix name, if the aldehyde is present as a principal functional group, then the name of the organic compound will end with al, AL. Right, and same way CN, it is cyano, which is the prefix, and nitrile will be the suffix, right? And C double bond O, it is ketone, right? The functional group is ketone. The prefix will be oxo and the suffix will be ONE, that is on. Right, and next is alcohol group. Yes, alcohol, if it comes as the prefix, it will be hydroxy. Yes, if it is present as the substituent group, we should prefix it, right? So it is hydroxy, and if it is suffix, it will be all. Right, next one is amino and amine. So amino group, in the prefix it will be amino, and suffix you write it as amine. Yes, next one is alkene, C double bond C, it is alkene. Alkene never comes as a prefix, it will be always a suffix, and that too the primary suffix, right? Yes, so it will be ene. Next is alkyne, C triple bond C, that is alkyne. So alkyne also, it never comes as a prefix, it will be always a suffix, and it will end with YNE, ine, right? Now moving on to the next one, that is X. X stands for all the halogens, right? Fluorine, chlorine, bromine, iodine. And the halogens never comes as the suffix. It will be always prefixed before the root word, right? So that will be halo. That means fluoro, chloro, bromo, iodo, right? Yes. Next one is nitro. The prefix name will be nitro. That also never comes as the suffix. Next one is OR. That is alkoxy. Okay. OR. This R stands for the alkyl groups. It can be CH3. It can be C2H5. The alkyl groups, the general representation is R. So that is alkoxy. Right? The prefix is alkoxy. Next one is R. What is R? It is the alkyl groups, right? Even alkyl groups always we represent it as prefix. It is never suffixed. Okay. Next one is sulfonic acid. The prefix is sulfur and the suffix name will be sulfonic acid itself. Right. The next one is COX. Okay, so this X again stands for the halogen groups, right? So as you can see, COCl, this is an example. It is an acid chloride, right? So halocarbonyl will be the prefix and the suffix will be OL halide. And the last one is COOR. It is ester, right? So the prefix will be alkoxycarbonyl and the suffix will be OH. So I hope it is clear. So in various situations, that is if polyfunctional groups are present, that means more than one functional group is present, the principal functional group will be present as the suffix and the other substituents will be present as the prefix. So based on their priority, the prefix and suffix name should be added to the root word. So let's do a few examples and get it cleared, right? So the first one, as you can see here, there is a double bond which is present here. Yes, as well as you can see a branch here, that is a methyl group. Okay, so as we studied just now, according to the priority list, yes, the double bond comes. That is, the alkene has more priority than the alkyl groups, right? So according to the priority list, this should be present as the suffix and the methyl group will be present as the prefix, right? That is considered as a substituent. Okay, so if a double bond is present as well as a methyl group is present, so the priority goes to double bond. So we should start numbering from that direction, right? So it will be 1, 2, 3, 4 and 5. Okay, so on the fourth position you have a methyl group. So what will be the IUPAC name? 4-methyl. Yes, it is 4-methyl. And how many carbon atoms are there? That would be the root word, right? So there are 5 carbon atoms. So the root word is pent. Yes, and as we can see, there is a double bond. So it is an alkene. And on which position this double bond is present? On the second carbon atom, right? So it is 4-methyl pent 2-ene. Right? The position of the double bond should also be mentioned. So it is 4-methyl pent 2-ene. So the suffix here will be ene. Right. Moving on to the next one. Again, you can see there are 2 functional. So moving on to the next one, you can see 2 functional groups here, right? One is alcohol and then you can see the acid as well, carboxylic acid. So now what we have to do? So this is a polyfunctional organic compound. 2 functional groups are there. So according to the priority list, carboxylic acid comes first. So that will be the principal functional group. So that will be added to the suffix. Now what about the OH? That is alcohol. OH will be considered as a substituent here. So the name will be prefixed, right? This will be considered as prefix and that will be your suffix, because according to the priority list, carboxylic acid comes first. So again, what we have to do? We have to start numbering. According to the priority, carboxylic acid comes first. So we start numbering from there. Okay, and as we studied according to the rule, if the functional group is containing carbon atoms, that should be numbered as first, right? So it will be 1, 2, 3, 4 and 5. Right. On the 4th position, you have the OH group. Now that must be prefix. So OH group, if it is present as prefix, what it is? 4-hydroxy, right? It is not ol, it is 4-hydroxy. How many carbon atoms are there? 5. So it will be pentanoic acid. Pentanoic acid. Okay, so the oic acid is the suffix because there is a carboxylic group there, and the pent is the root word and stands for the alkane, right? So it will be 4-hydroxy pentanoic acid. Clear? Now moving on to the next one. So now moving on to the next one, the functional group which is present here is aldehyde, right? So it is C double bond OH it is. Actually this is the functional group, right? Okay, so if the functional group is having the carbon atom, we should start numbering from there. So this will be the first one, 2 and 3, right? And on the third carbon atom, you have a chloro group attached as well. So what will be the name? The chlorine will be present as the substituent, right? So it will be 3-chloro. And how many carbon atoms are there? 3. So the root word will be prop. Yes. And the functional group is aldehyde. So what will be the suffix? It is propanal. It will be Al, right? So it is 3-chloropropanal. Okay, now moving on to the last one. Yes, it is Cl2CH2OH. Again, what is a functional group here? There is a OH group, that is alcohol group is there, and you can see 2 chlorine atoms as well. Yes, so from which side I have to start numbering? From the functional group side, right? So it will be 1 and 2, right? And on the second carbon atom, you have 2 chlorine attached. Yes, so what would be the name of the organic compound? It will be 2, 2. On the second carbon atom, 2 chlorine atoms are there, right? So 2, 2 dichloro, right? Dichloro. And how many carbon atoms are there? 2. So it is eth. The root word is eth. Yes, and the functional group is OH. So the suffix will be ol. So ethanol, right? 2, 2 dichloroethanol. So I hope it is clear how to name the organic compounds containing functional groups as well, right? Yes, and if there are more than one functional group, according to the priority list, one should be considered as the principal functional group and the others will be considered as the substituents, right? Yes, I hope it is clear. So now moving on to nomenclature of substituted benzene compounds. So substituted benzene compounds means on the benzene, yes, you're familiar with benzene, right? On the benzene ring, you will be able to see other substituent groups also. So in such cases, how do we name the organic compounds? Let's see, right? So first of all, let's have a quick revision about the benzene ring itself. As you can see, all this representation is for benzene itself. There are 6 carbon atoms. Yes, and you can find alternate double bonds as well, right? Alternatively, you can see the double bonds present and there are 6 hydrogen atoms also around it. So this is the complete structural formula and this is the bond line structural formula that you can see. And yes, this double bond, the speciality of this alternative double bond is they undergo delocalization, right? So this double bond can come here, this can come here, this can come here. So that will give you this particular figure. So that means this continuous delocalization of pi electrons can take place. So that means altogether we can represent it like this. So this is the representation of benzene. Now moving on to the naming. How do we name it? The naming of monosubstituted benzene. That is, only one substituent will be present on the benzene. So in this case, it is derived by adding the name of the substituent with the word benzene. Whichever substituent is present there, that will be named as the prefix and the name will end with benzene. Okay? Yes. So that means the substituent name plus benzene will give you the name of the organic compound. So let's understand it. The first one, as you can see, there is a benzene ring. This is a monosubstituted benzene, right? On the benzene, there is one single substituent which is present, which is methyl. Right, it is methyl. So what is the name of the organic compound? The substituent name plus benzene. It will be methyl benzene. Okay, this methyl benzene. Moving on to the next one. The substituent is bromine. So it is bromobenzene. Next one is nitrobenzene. The prefix is nitro, right? Nitrobenzene. Now here the substituent is OMe. Now what is Me? Me is the short form written for methyl group. That means CH3 group. So OMe is OCH3. Right, OCH3 it is. So what will be the prefix then? Methoxy. So methoxy and it ends with benzene. Okay, so for monosubstituted benzenes, the substituent name is written first and then followed by benzene. Okay, so now moving on to some special names for certain monosubstituted benzene compounds. Right, so the first one is, yes, just now we discussed methyl is the derivative which is present on benzene. So the IUPAC name is methyl benzene. Yes, but methyl benzene can also be called as toluene, which is a special name which is given to it, toluene, right? So the next one is NH2 group present on the benzene. So the IUPAC name is benzenamine or aminobenzene, and the special name will be aniline. So if you find benzene ring and on top of that benzene ring, it is substituted by a NH2 group, it will be called as aniline, right? The special name is aniline. So this special names is also accepted by the IUPAC, right? Next one is OH group present as substituent. The IUPAC name will be hydroxybenzene. Yes, hydroxy and benzene, right? But the special name is phenol. So wherever you see this organic compound, it will be generally named as phenol, right? Now moving on to next one, benzene ring and a aldehyde group is present as substituent. So the IUPAC name is benzene carbaldehyde, but the common name that we use is benzaldehyde. The special name is benzaldehyde. Next is benzene group, and then we have a COOH, that is carboxylic acid. IUPAC name is benzene carboxylic acid, and the common the special name is benzoic acid. Next one is benzene and OCH3. We just discussed now. It is OCH3. That is methoxybenzene. Methoxybenzene will be the IUPAC name and the general name is anisole. So all these special names are also accepted by the IUPAC. Now moving on to the next part. If the functional group is attached to the carbon chain connected to benzene ring, then benzene ring is considered as a substituent and is prefixed before the root word as phenyl. Okay, so now if benzene ring is present as a substituent, that will be prefixed and written, and the prefix word is phenyl. So as you can see in this example, this is taken as the principal chain, right? And then on the first carbon atom, you can see, yes, what you can see, there will be a benzene ring which is present. So now this benzene ring is considered as the substituent. Okay, so this is your principal chain and this is the substituent. So how would you name it? This will be present as substituent means, yes, that should be in the prefix, right? So it is present on which carbon atom? From where should I number it? I should number from here. The functional group is present here, right? So we number from that direction. So in the third carbon atom, you have phenyl. It is not benzene now. It is prefixed. So it is phenyl. 3 phenyl. How many carbon atoms? Prop. Yes, 3 carbon atoms, so it will be prop and the suffix will be al. So 3 phenyl propanol, right? Moving on to the next one. Again, this is your principal chain, and then on this carbon atom you have a benzene group. Now that is considered as the substituent. Okay, so on the 1 and 2, on the first carbon atom we have the chlorine attached, so 1 chloro. And on the second one, phenyl group is there. So 1 chloro, 2 phenyl, and it is ethane, right? Any other functional group? No. So it is 1 chloro, 2 phenyl, ethane. So 1 chloro and 2 phenyl. Why exactly in this order? Right. C comes first, then P in the alphabetical order. So 1 chloro, 2 phenyl, ethane. So now moving on to disubstituted benzene compounds. That is 2 substituent groups will be present on the benzene ring. Okay, so if the substituents are the same, in such a case, the relative positions of the substituents must be indicated by adding the symbols ortho, meta or para, or it can be represented as 1, 2, 1, 3 and 1, 4. So before moving on to how to name it, we should be knowing what is ortho, meta and para positions, right? So if we consider this particular organic compound here, there is a substituent which is present. So it is disubstituted organic compound that we are talking about, right? So if one more substituent is present here, yes, just beside it, it can be present here as well as on the 6th position. Then it is called as ortho position. Just beside the substituent group, if 2 groups are present, they are called the ortho position. And the 3rd and 5th positions is called as the meta position. And the direct opposite position, that is 4th position, it is called as para position. This can be used in the trivial system, that is ortho, meta and para. Yes, the ortho is 2 and 6 position, that is ortho, 3 and 5 is meta and 4th one is para. So this can be used in trivial system, but in the IUPAC nomenclature, this should not be used. The numbers should be used. So how do we number it? 1, 2, 3, 4, 5, 6, right? So if ortho position you have to represent, it will be 1, 2, right? And if it is meta position, 1, 3. If it is para, 1, 4. Right. So in the common system, you can use O, M and P for ortho, para and meta, but in the IUPAC, you are not supposed to use it. Right. Yes, so I hope it is clear. Now, let's take an example. Yes, on the benzene ring, it is disubstituted and both are same also. Both are halogens, that is chlorine. Right. So, how do we number it? 1, 2, 3, 4, 5 and 6. So, on the first and second carbon atom, yes, you have the chlorine groups or chloro groups attached, right? So, actually it is on the first and second position. So, it is ortho, right? First and second, so it is ortho. But in the IUPAC nomenclature, it should be 1, 2, right? 1, 2 and how many chlorine? 2 chlorines, right? So, 1, 2 dichloro. Yes, dichloro and the name should end with benzene. That's it, dichlorobenzene, or it can be written as ortho-dichlorobenzene as well. Instead of writing 1 and 2, it is ortho, but it's not accepted in the IUPAC system. Right. Next one, 2 nitro groups present. Yes, it is present on the meta positions, right? But coming on to IUPAC, 1, 2, 3, 4, 5 and 6 on the first and third position. So 1, 3 dinitrobenzene. Yes, so I hope it is clear. Now, moving on, if the two substituent groups are different, yes, the substituents are written in the alphabetical order. So, till now, disubstituted benzene we were talking about, both the substituent groups were same. Now, if the substituent groups are different, then we have to name it according to the alphabetical order. So, as you can see here, the two substituents is iodine and bromine. According to the alphabetical order, it will be bromine which comes first, right? So, we start numbering from here, 1, 2, 3, 4, right? Yes, so the first position, bromine is there, so 1 bromo, and the fourth position, iodine is there, so iodo, 1 bromo, 4 iodo, and the principal chain is benzene, right? So, it is benzene, 1 bromo, 4 iodo, benzene, or it is also para-bromo iodo, benzene. It is present in the para position, right? Okay. Now, the next one, there is a chlorine and nitro. So, there is a chloro group and nitro group, right? Both of them are present as substituents and we should be naming it in the alphabetical order. So, 1, 2, 3, 4, 5, 6. Yes, so 1 chloro and third position nitro group, right? So 1 chloro, 3 nitro benzene, or it is metachloronitrobenzene, 1 and third position, right? So it is metachloronitrobenzene, right? Coming on to the last one, there is a OH group in benzene. That means this is a phenol, right? Okay, so the principal chain you can consider it as phenol, and there are two substituents here, that is 2 methyl groups, and from where I have to start numbering from the functional group, right? 1, 2, 3, 4, 5 and 6. So in the third and fourth position you have 2 methyl groups. So 3, 4 dimethyl, it is phenol, right? The whole of it is phenol and 2 substituents are there. So 3, 4 dimethyl phenol, right? So I hope it is clear. Now moving on, if there are more than 2 substituents, okay, if there are more than 2 substituents, how would we name it? Okay, so in this case, a benzene ring is there. There is one bromo group, methyl group and chloro. Okay, so yes, as said, according to the alphabetical order, we have to name it. So from where we will start numbering from here. So 1, 2, 3. Okay, so the name should be in the alphabetical order. So bromo comes first, right? So 1 bromo, then comes chlorine, then last comes methyl in the alphabetical order. So 1 bromo, 3 chloro, 2 methyl, what it is? Benzene. Right. So moving on to the next one, there is a carboxylic acid present here. Yes, and then chloro and nitro. So on the benzene ring, if there is a carboxylic acid present, yes, it is benzoic acid, right? So the suffix and the root word will be benzoic acid. Now these two are present as the substituents, right? So from where we should start numbering? From the functional group, right? So 1, 2, 3, 4. Okay, so it will be 4 chloro, 3 nitro benzoic acid. So I hope it is Clear. So now let's see few examples based on this. So the first question, as you can see, there is a functional group. Which one it is? It is an alcohol group, OH, right? So it is an alcohol group. So from which direction we have to start numbering? The functional group containing carbon should get the lowest possible number, right? So we number from this direction, 1, 2, 3 and 4, right? So on the which carbon atom? The functional group is present on the second carbon atom. So the root word will be but. Yes, and the primary suffix will be ane. It is an alkane, right? So the primary suffix will be ane, and on the second position the alcohol is present. So 2 and ol. So the name will be butane 2 ol. So the suffix will be ol because the functional group is alcohol. Now moving on to the next example, that is CH3CH, and on this carbon atom there is a branch. Now what is this branch? This is ethyl, right? CH2CH3, it is ethyl group. And then you have a functional group which is present here, C double bond O, it is ketone, right? And then a CH3. So the functional group containing carbon should be getting the lowest possible number. And one more thing you have to keep in mind, yes, the functional group containing carbon should be present in the principal chain as well. So I can't consider 1, 2, 3, 4. I can consider this one, but I can't consider this chain. That is 1, 2, 3, 4. In either ways, it is 1, 2, 3, 4. Yes, 4 carbon atoms, but the functional group should be present in the principal chain. So that means we should take this as the principal chain. So now the next step is to number the carbon atoms. From this side we will start, right? 1, 2, 3 and 4. So on the third carbon atom, the branch which is present, it is ethyl, right? So 3 ethyl, and how many carbon atoms are there? 4. So the root word will be but. It is an alkane, so ane. And on which carbon atom the functional group is present? 2. So 3 ethyl, butane, 2 one. The suffix for ketone group is one. So 3 ethyl, butane, 2 one. So moving on to the next example, that is this a benzene ring? No, right? There is no alternate double bonds present. This is cyclohexane, right? It is cyclohexane. So the root word will be hex, yes, and the suffix will be ane, and the prefix here is cyclo. The secondary prefix here will be cyclo. Now the two substituents present is chloro and bromo. According to the alphabetical order, bromo will come first. So from where should I start numbering? From bromo, right? 1, 2, 3, 4, 5, 6. So it will be 1 bromo, 3 chloro, cyclohexane. Right, it is not benzene, it is cyclohexane. Right, now moving on to the next one. Yes, there is a benzene ring, and on top of it you have the substituent which is OCH3. Yes, this is methoxybenzene, right? It is methoxybenzene, right? Methoxybenzene, or the special name is anisole, which is also accepted by IUPAC. So I hope the nomenclature part is clear for you. So by this session, we have completed the nomenclature of straight chain alkanes, branched chain alkanes containing functional groups, yes, polyfunctional groups as well as cyclic compounds, and then we also studied the nomenclature for substituted benzene compounds, right? So in the next session, we are going to study the next topic, that is isomerism and the fundamental concepts in organic reaction mechanism. So the mechanism of the various reactions we will study in detail from the next session. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.